Hello children, welcome to the online class. So here is our third class in science chapter. Okay, so before we proceed to the chapter, I would like to conduct a small test for you. Okay, so here go through these questions and try to analyze the answer on your own based on whatever you have learned in your previous class. The question number 1, dash thermometer is used to measure the weather temperature. So here are 4 options for you. Option A, maximum minimum thermometer. Option B, clinical thermometer. Option C, laboratory thermometer. And option D, none of the above. What could be the answer? Is it option C? No. It's option D? No. So here 2 choices left for you now. Maximum minimum thermometer and clinical thermometer. So what it could be to measure weather? It is obviously not clinical thermometer, it is actually maximum minimum thermometer. Okay, the second question, body temperature can be measured by using laboratory thermometer. Sorry, body temperature cannot be, there is a small mistake here, it should be actually cannot be measured by using laboratory thermometer due to the absence of kink in it. Okay, there is a small corrections here. So the answer is KINK, kink. Okay, so we cannot measure the body temperature using laboratory thermometer. We can measure only using clinical thermometer. Okay, because in clinical thermometer only kink will be present, but whereas in the laboratory thermometer kink will be absent. Kink is something like, as I said in the previous class, consider this is the thermometer. So below the thermometer there will be a small kink like this. Okay, so this part is the kink. This will be usually present in the clinical thermometer, where the mercury will not drop immediately after you measure the temperature, but whereas the laboratory thermometer will be exactly straight and directly bulb will be there in the laboratory thermometer and no kink will be present. So as a result, the mercury will immediately drop, okay, as soon as you take it out from the object. This I have already discussed in the previous class. Now next question, true or false? Kink prevents mercury level in thermometer from falling on its own. Is it true or false? Yes, absolutely it is true, because of the presence of this kink only. Okay, so mercury will not drop immediately. So that is the reason why we use the clinical thermometer to measure the body temperature. So it will give you the accurate body temperature. So now let's do a quick recap of what we have learned in the previous class. So we learned that to measure the temperature of different objects like boiling point of water, etc., we use which thermometer? Laboratory thermometer. And the range of laboratory thermometer is from minus 10 degrees Celsius to 110 degrees Celsius. And maximum minimum thermometer is used to measure the weather temperature. So these things we learnt in our previous class. So now let's move on to the next part of our chapter, that is heat. So shall we begin the class? Okay. So here are a couple of learning objectives for you. So today we are going to learn about transfer of heat. So how heat transfer takes place in an object. So that we are going to learn. So the main objective is only one objective we have. That is the ways, the different ways through which the heat transfer takes place in the object or in a body. Okay. So that we are going to learn in today's class. So what is actually transfer of heat? As you might have observed in your kitchen, so when your mom prepares food, any delicious food, she will use some kitchen utensil. Okay, so let us consider frying pan and all. So when we keep the frying pan on a stove, so in stove heat is generated. So when the heat is generated, the heat gets transferred from stove to the frying pan, right? So when you touch the surface of the frying pan, you will feel the hotness of that object. So frying pan gets hot when the stove transfers heat to the frying pan or whatever the vessel which you have kept in the kitchen. Okay, and few more examples I'll quote. So frying pan becomes hot when kept on a flame. So this is one example where you can able to demonstrate the transfer of heat. The same frying pan, okay, after you take it out from the stove and keep it idle for a few minutes. So what do you observe? After removing from fire, it slowly cools down, right? So what do you think? In both the cases, heat transfer has happened. Now you can ask, sir, heat transfer means only when in the first example, when the stove gets heated up, so it transferred the heat right to the frying pan. So when the frying pan becomes hot, is it only the transfer of heat? No, it is not only the transfer of heat. Even this object which is getting cooled is also considered as an example for a transfer of heat. Now I'll exactly explain you what is transfer of heat. See, whatever you take, now consider this frying pan. In general, frying pan or any object which is present, we consider these objects as a system. We consider these objects as a system. So whatever is present outside, that is the air which is present outside, we generally call it as air. So we can call generally as surrounding. We can call it as surrounding. So the air which is moving continuously, we can only feel it, we cannot see it, right? So we can consider that as a surrounding. That's the reason why you can feel the room temperature vary accordingly. So in summer season you will feel sweating because the room temperature increases in the surrounding, so you will start sweating. Whereas in the winter time the room temperature will be low because outside temperature, that is surrounding, the air which is present will be not too hot, it will be cold actually. That's the reason why you will feel chillness during winter season or during rainy season, right? So the same thing here also, the transfer of heat is taking place. So in the first case, what happened? Okay, the heat is transferred. Already this stove is hot because of the flame, burning flame. So from hot object to a cold object. Before I placed this pan on the stove, the pan was cold, right? The pan was in normal room temperature. So from hot to cold object, the heat got transferred and that object has become hot. Now when I again place it outside, so what happened here in the second case? So the object which was hot, it is releasing the heat to the surrounding. So it tries to attain to the normal temperature. It tries to attain to the normal temperature, that is the temperature which is present in the surrounding. So it starts cooling down. So here also what is happening? The transfer of heat is happening. So I'll quote with some other examples so that you will understand about the transfer of heat in depth. Okay, now here let's move on to the another example. Just give me a minute, sorry. Now so what do we infer from the previous example? We can say that the heat flows from hot object to cold object. Always remember, the heat always flows from hot object to cold object. So in the beginning also, in the previous example when I quoted, in the beginning also, okay, the frying pan was not hot actually, but the stove was hot due to the flame which is present in the stove. So the hot object, the flame is trying to transfer its heat to the cold object. So before I kept the frying pan on the stove, the frying pan was cold, okay, and that's the reason why So the transfer of heat took place from stove to frying pan. In the second case also, what is happening? So the frying pan, now it is too hot because I have taken just now from stove. So the frying pan was too hot. So when I try to place it outside, so the hot frying pan is trying to transfer heat to the cold surrounding, right? So usually in any case, the transfer of heat always takes place in this manner only. So the heat transfer or the heat flows from hot object to cold object. Okay, please keep that in mind. So here one more example I'll tell you. Here it is something like an activity which is given in your book. If I would have been in the class, I would have demonstrated you this activity. But now since we are not in the class, so we are not in the live class actually. So since we are in online class, I request you guys to try this activity at your home. Okay. So what you can do is take a candle, okay, and place any brick or any two stone like shape, and in between you attach a metal scale. Okay, so just to actually we are doing a small activity here where we can able to determine how the transfer of heat is taking place. So here, just to hold a grip of that scale, we have to keep the stones or any other object also you can keep. Make sure the object should not melt. Okay, now place the candle at the front of this scale, okay, at the starting point or the tip of that scale. Now burn the candle. So when you burn this candle, so the transfer of heat will take place, right? Because the candle, the flame is touching the scale. So like this position only you have to keep. So as the heat progresses, the heat will flow throughout the scale and the wax will start developing. Okay, as it as the temperature becomes cold, the wax will start developing. But then in few places the wax will immediately melt and it will fall down also. So now you can observe and tell in which position the wax melts quickly or the wax melts immediately. So as you can see here in this scale, in all the positions the wax has been formed, but the wax which has formed nearest to the candle flame, that is only is getting melted fast. The reason being, so the heat is getting transferred from hot object or the hot area to cold area, right? So in that scale, the position of the scale where the candle light or the candle flame is near, okay, in that position the hotness will be more, and as a result this wax will start melting easily. But whereas when you move along for some distances, for some farther distances from the flame, since at that position the flame effect will not be too much, okay, it will be less. So as a result the wax will not melt immediately, it will try to attain the temperature of the surrounding. So the transfer of heat, where it is happening more, it is happening on the region where the flame exists, and as it moves on, so from hotness it becomes cold. So you can easily determine that how the transfer of heat takes place from hot object to cold area. Okay, so what happens to the wax pieces? Here there are few questions which you can able to answer it after doing this activity. So what is happening to the wax pieces? So the wax pieces starts melting. Okay, first the wax pieces will start to form in all the areas of the scale. Okay, but then do these pieces begins to fall? Yes, it begins to fall in the region where it is close to the flame, where the temperature is high. And the third one, which piece falls first? So the piece which formed near to the flame or nearest to the flame, where the heat or the temperature is high. So in that position what is happening? The wax is melting. Then fourth one, do you think that heat is transferred from the end nearest to the flame to the other end? Yes, absolutely. So the heat will transfer from the nearest to the farthest point of the flame. Okay, that's how the heat transfer will take place. So it will always the heat transfer always takes place from hot region to cold region. Okay, so this you need to understand. Now here we come across a topic called conduction. So what is conduction? So the process by which heat is transferred from hotter end to the cold end of an object is known as conduction. So this process, whatever I have explained now, so how the transfer of heat is taking place from hot area to cold area or hot object to cold object. So this process only we call it as conduction. Okay, so in a physics terminology we call this as conduction. So here are a few more examples of conductions I have given. So you can see here. So what is this actually? In the first example you can see a hot tea which is kept outside. So since the tea is hot, what is happening? The heat will transfer from tea to the surrounding. So room temperature will be lesser than the temperature of the tea. So what will happen? The heat will transfer from hot tea to the surrounding. Okay, that is the reason why outside the arrow mark has been placed. So the arrow mark has been denoted outside the teacup. Whereas in the second example, the ice cream, since it is a cold object, okay, so that is why it is in solid form. So if I take out the ice cream from the refrigerator or the freezer, so when I start holding the ice in the normal temperature or the room temperature, so what will happen? So again the same thing will happen. The surrounding temperature will be more now. The surrounding, it will be too hot. So what will happen? It will try to transfer the heat from the surrounding to itself. So that's the reason why the ice will start melting. Okay, so here you can easily understand how the transfer of heat or the conduction takes place from hot region to cold region. Another example, as I said already in the previous example which I have denoted using the candle. So how the transfer of heat takes place in the candle is been denoted using this thing. So you can see here the red marks, the red dots shows up to that range it will be too hot. The transfer of heat, we can consider it as a hot region. Okay, the transfer of heat will be more in the hotter region. Then as it moves on little bit away the distance, okay, as it moves away, so what will happen? In the blue dots which has been showed, we can consider it as a colder region. There the heat transfer will be somewhat lesser. Okay, so the temperature will be somewhat less when compared to the distance which is near to the flame. Now, do all substances conduct heat easily? So by using that analysis, we can also try to do an activity where you can able to identify that whether all the substance, not substance actually, we can consider it as objects. So do all the object conduct heat quickly, or do all the object has capacity to grab the heat? Okay, so that we can able to do or analyze using a simple activity. So what you need to do is you need to take a few things like steel spoon, plastic scale, pencil and divider. Okay, and then you should mention material with which the article is made up of. So which material, whether it is, if it is made up of metal, so you should denote it as metal. If it is made up of plastic, you should denote it as plastic. Okay, then does the other end gets hot? If it is getting hot, then you should mention it yes, and if it is not, then you should mention it as no. So what you have to do, steel spoon you take and you try to bring it near to the flame. Candle, you can just light up a candle and near the flame of the candle you just keep the steel spoon. So for a few minutes, not too don't make it too hot. Okay, just keep it for a few minutes, and if the surface of the steel spoon becomes hot, then you can say that the other end is getting hot and you should mention it as yes. So since steel spoon is made up of metal, absolutely it will become hot. The conduction is good in metals, so you can say that yes, it is happening. So the other end gets hot, so conduction is taking place. Then same thing, you take plastic scale and you try to keep it. Okay, so material with which the article is made up of plastic scale, it is made up of plastic. So plastic actually, when you try to keep it on the flame, the plastic will not conduct much heat, instead it will start melting immediately. Okay, so you can say that plastic is a poor conductor. It's not like it is not completely conducting, but it will conduct, but it is a poor conductor of heat. Okay, so you can say the other end will not get hot, so you can term it as no. That's the reason why you might have observed, if you take cooker or frying pan or whatever it is, so the cooker handle or the frying pan handle will be made up of plastic, hard plastic, not the soft plastic. It will be made up of hard thermosetting plastic. And that the reason being why it is made up of hard plastic means plastics are bad conductor of heat, or we can say insulator of heat. The opposite of conductor is insulator. Okay, so the plastics are bad conductor, it cannot absorb heat, so we use the handles of the cooker or pan which will be made up of plastic. The same way pencil, divider. So pencil is something like one part of it will conduct and one part of it will not conduct, because pencil is almost made up of wood. So wood will take time to conduct. It's not like it will not conduct, it will take time, more time to conduct heat. Then divider is again made up of metal, so it will conduct quickly. Okay, so now what do we infer from the previous activity? We can say, so the material which allows heat to pass through them easily. So those materials which can allow them to pass the heat or the transfer of heat which can able to conduct easily, those materials we call them as conductors. Example, as I said, aluminium, iron, copper, etc. In general, almost all the metals will conduct heat. So what is the opposite of it? As I said, insulators, we term it as insulator. So the materials which do not allow heat to pass through easily, they are considered as poor conductors of heat. For example, plastic, wood, etc. So poor conductors are otherwise known as insulator. Okay. So few more examples of conductors and insulators of heat. As you can see here through this picture, through this diagram, you can able to easily determine which objects can conduct heat easily, which objects cannot conduct heat quickly or easily. Okay, so here conductor side you have aluminium, jar lid, nickel, nails, key. So all these are made up of some sort of metal like iron, aluminium or whatever, nickel. So that's the reason why they are good conductor of heat. As I said, pencil is kept at the center because they may act as both conductor and insulator. The reason being, the tip of the pencil is made up of graphite, which is a metal. So that will conduct heat, whereas the wooden part will not conduct heat quickly. Okay, so that is the reason why it is like, in between. Okay, so they can consider as we can consider pencil as a conductor also, insulator also. Whereas the common insulators are wood, toothpick, cardboard strip, rubber band, Q-tip, cloth spin. So all these are actually the best insulators. Insulator means which will not transfer heat quickly. I am not telling that they will not transfer heat at all. Remember that. They will also transfer heat, but they will take lot of time to transfer heat. Okay, they will take more time to transfer heat. So these objects we can call it as insulators. Okay, so with this I'll conclude my today's class. So before I conclude my session, I'd like to give a quick recap of what we have learned today. So what are all the things we have learned today? So we learned that heat generally flows from hot object to cold object. As I said, in general, this is a common phenomena. Please remember that. So heat always flows from hot object to cold object. And the process by which the heat is transferred from hotter end to the colder end of an object, we call it as conduction. So that process we call it as conduction. And the material which allows heat to pass through them quickly, they are called conductor. And The material which do not allow heat to pass through them are called insulators. Okay. Now let us have a quick assessment of what we have learned today. So the assessment is something like give two examples of conductors and insulators of heat. So you just have to mention any two examples of both conductors and insulators. And second one, a cold steel spoon is dipped in a cup of hot milk. It transfers heat to its other end by the process of dash. So by which process the transfer of heat takes place, that you need to fill. Okay, so you can answer this on your own in your classwork notebook and just publish it in your WhatsApp group. And here is a home fun for you. So the home fun is also like a simple activity which you can try to do it at home. So wrap a thin paper strip tightly around an iron rod. So you can take a small iron rod and try to wrap a thin paper strip tightly. Make sure it will not move, it will not get removed. So you should wrap it tightly. Try to burn the paper with a candle while rotating the iron rod continuously. So does it burn? So explain your observation. So while doing this activity, make sure some adult supervision must be there. So don't do it on your own. Try to get the parents' assistance while doing this activity. So just do this activity and let me know whether through this process the paper gets burned or not. Okay, if the iron gets conducts easily, which means the transfer of heat, if it takes place quickly, then the possibility is that paper will burn. If not, it will not burn. So just do this activity and find out and let me know. Okay, so till we meet next time, take care children, have a good day, bye bye.